Hello everyone, I hope all of you are doing well. Thank you for the overwhelming response that I've gotten so far in the Excel sheet that I just floated, wherein I kind of asked you for a lot of questions that you have while making a transition into data science slash machine learning. So I thought of picking up a question quickly so that I can give you a small demonstration on how quickly I'll kind of start releasing videos once you start updating questions as well on the sheet that I've just shared. So I got a very important question that a lot of you have in your mind when you are thinking of making a transition to data science and machine learning. So let's jump directly into the question.
There were a couple of similar questions asked in the Q&A form that I had circulated, and grouping two of them together, here are the questions that I would like to answer in this video. Is steering the algorithm a good practice in the industry? Like not using the packages but using your own steps to arrive at a similar result? What would be the parameters on which a model developed is checked/implemented? So let's go back and try to understand what the best practices are in terms of implementing algorithms from scratch.
Now that you know what the question is, let's jump directly into the answer. But before I actually jump into the answer, let's kind of wait for a while and let me show you something. So see this. So let me start off with a very simple story. It was the year 2012 and I had recently purchased a tablet. So tablets were like a big thing at that point of time. Let me switch this on to demonstrate that this is still in a working condition. As all the famous tech YouTubers kind of maneuver their tech devices, here's a simple way of me showing off the tech that I own. The way tech has evolved, you can see the animations are really slow. So it's not 90 hertz, it's just 60 hertz screen that is there. So sometime back there was some issue that crept into this device as well. It wasn't functional as the way it should be. So I went to a service center. They kind of changed a lot of internal parts and they brought it to life at that point of time. Ideally, if I knew how this device worked in and out, then I would have been in a position to handle the problems that the device was facing. So essentially, it's a good to know have activity if you can kind of tweak around things of black boxes that you're not aware of. It's always a good activity to know what's inside the black box to understand how the whole thing is functional. But the flip side to it is you cannot keep having things. So I basically own a USB drive as well. So I cannot keep remembering all the working. I cannot implement a USB drive from scratch at my end. I also own a Sony camera, so essentially, if I start understanding all the devices end to end and if I start implementing them from scratch, the amount of time that I would invest would be really huge. So, what is the whole crux of this small demo that I've showed you is what you'll find out in the next section. So, let's jump directly to that. Now that you've seen what essentially I wanted to show you, I wanted to give you different use cases for the same question and how the industry reacts is what I'll kind of come to. The question is fairly simple. Do we need to implement each and every algorithm that we come across in the field of machine learning and data science from scratch? How do I answer this? Should I say a yes? Should I say a no? Well, I would say wait. I'll give you an answer, but maybe not in the form of like a yes or a no. Okay. So let's start with the first part of the question. That is, irrespective of if you implement an algorithm from scratch or not, but you should know the mathematics behind every algorithm that you've ever used in your life. So if I ever mention XGBoost on my resume, then essentially I should know how XGBoost works. If I've ever mentioned that I've done a sequence modeling based exercise using an LSTM model, then essentially I should know how an LSTM model works as well. So the mathematics behind an algorithm is of prime importance. That is something that I would highly encourage all of you to practice. Even if you don't get time to implement algorithms from scratch, it is okay. But not knowing an algorithm and still mentioning it in your resume or still feeling confident about an algorithm by just fitting an algorithm is not the right approach. So the first thing that I want to clear out and lay foundation on is the mathematics piece. Every algorithm, be it a simple decision tree, be it as complex a tree based model like random forest, be it support vector machine, whatever you can fit, Essentially, you should know what goes behind the scenes for that fit command to run. You may or may not get time to implement algorithms, but ideally you should know each and every part of the mathematics that is behind the algorithms. Now, coming to the second part of the questions, in the industry, do we implement algorithms from scratch every time? Let me answer this. So, say for example, I create a defaulter model. The first model that I create is a logistic regression model. Now, this model, considering logistic regression is kind of a simple algorithm to implement, I implement this from scratch and I get an accuracy score of around 85%. I take SVM and I don't implement it from scratch. The business does not even care about the model interpretability part. It just wants an accurate model that feeds in some inputs, that is your features, and expects me to tell that whether this person is gonna default or not default. In such a situation, implementing the model from scratch or say implementing an algorithm using a package does not kind of account to what the company is kind of using the model for. Now, if someone comes out and asks me a question, how does SVM work? That is the time my algorithm understanding would come into picture. I should be in a position to explain how support vector machine works, given it creates a margin and kind of tries to separate out both the classes so that you have a fairly accurate model in place. So again, how do industry or how do companies work? It's essentially on how or what they're trying to achieve using the model building exercise. If it's a research organization that is kind of coming up with new NLP, say language models, that is where you would need to implement things from scratch because you're kind of modifying the existing algorithms or you're not happy with the existing algorithm in terms of the implementation piece. That is where you have to go on and implement things from scratch. But most of the times, people do rely heavily on the predefined packages which are available so that you spend less time in actually building the model and more time in terms of understanding data, cleaning data, and then going on and deploying the model as well. So the model creation activity, thanks to scikit-learn, thanks to TensorFlow, thanks to PyTorch, all the exercises have been very much abstracted out in terms of model building. You just have to fit and predict. Given you know the previous steps, that is hyperparameter tuning, k-fold cross validation, and the other processes which are involved in model creation. So I would highly encourage all of you to know the mathematics from scratch and not worry about implementing each and every algorithm from scratch using Python. Yes, it's a good activity to have, but essentially you cannot sit down and implement every algorithm that you find. The organizations mostly rely on return on investments. That is where I think your understanding of the algorithm comes in very handy rather than the actual implementation from scratch. Having said that, implementing algorithms from scratch also plays a very vital role in some unique use cases. So I was working on a time series based problem wherein I had to create an outlier detection algorithm that works at scale. Now, I would urge you to perform or pick up an exercise. I want you to do a Google search and find out if there are any directly available packages that can help you detect outliers on big data. When I say big data, I mean to say around say 5 GB, 10 GB of data using PySpark itself. If there's anything that you find apart from TS Arima model, then please feel free to share it across with me. The reason why I'm so confident right now is because I've kind of worked on this problem end to end. We had a challenge that we have GBs of data in hand and we want to find out outliers in that data set. Now, given the scale at which we were working on, we couldn't rely on predefined or pre-trained models as such. We couldn't even say use deep learning because we were dealing with different cuts of data. That is where understanding of algorithms going through research papers comes in handy, so that when a task comes in where there are no such packages available, the one that I kind of just encountered, you are well equipped to actually create your own algorithm from scratch. So again, a very clear indication that I can give you is try enjoying the mathematics behind algorithms. And also, if you get time, there's no harm, absolutely no harm in implementing algorithms from scratch. Yes, there would be a threshold that you would reach once you kind of implement say 5, 10 algorithms. You cannot keep going on implementing algorithms as well because that So that consumes a lot of time, which kind of becomes really impractical going forward as well. So again, if you have time, you're more than welcome to try out every algorithm that you kind of encounter. But if you're kind of running short on time as well, then I would highly encourage all of you to understand the mathematics end to end, go through the entire research paper, and then come up with your own sense of understanding. And if you actually want, or if you actually are very keen on implementing algorithms, please feel free. But for most of the people out there who want to kind of get a break into data science and ML, I would highly encourage you to not go all out and implement every algorithm from scratch. But yes, understanding the mathematics will play a very pivotal role in terms of you making that right transition from your current non-data science or non-ML role to an actual DS or an ML role. So I hope you found this video informative. If you really like the content that I share on this channel, I would highly encourage you to click on the subscribe button to be notified for future videos. And also, if you could press the bell icon so that you don't miss out on any small update that I share. This costs you nothing, but ideally this motivates me to make more and more such amazing videos. Thank you so much for watching the video. And by the way, the document is still in the description section of the video. Feel free to post any other questions that you have so that I can pick this up and kind of say run with the videos as soon as possible. Thanks again for watching the video.